Example 7. Implicit differentiation in multiple quantities. The area A and radius r of a circle are related by the known equation A equal to pi r squared. Suppose that the radius is changing over time. What can you say about the rate of change of the area? Again, we're bringing this back because this is somewhat an implicit differentiation, and you see it over and over again, and you see a lot of it in 3.10. And so what is happening is that you can both r, a, and r are functions of time, and we can implicitly differentiate the equation with respect to t. So let's do that. And then the result is the left-hand side is going to be dA dt. The right-hand side is pi derivative of r squared respect to t. What is derivative of r squared? That is, pi is the constant coefficient. Then you multiply it by using chain rule, that is the generalized power rule. So it's 2r times dr dt, because the inside function is r, and it's not, we're taking derivative with respect to t, not with respect to r. And so this, for example, if the radius is currently 10 centimeter and is decreasing at a rate of 4 centimeter per second, then instantaneous rate of change of area is going to be, by plugging the 10 and the negative 4 in here, you're going to get a negative 80 pi centimeter squared over a second. And so that this comes back and back, and we're doing the chain rule, we're implicitly differentiating because there are multiple variables, they're all functions of time, and then we end up with solving the rates, the related rates, basically. So let's do an I-clicker question. I-clicker question 4. Boyle's law states that the absolute pressure exerted by a given mass of an ideal gas is inversely proportional to the volume it occupies. If the temperature and the amount of gas remains unchanged within a closed system, constant K is going to be equal to P times V. Assume K is constant and P pressure and V volume are variable. So two things are changing, one of them is constant. Which equation represents the change in pressure with respect to time t? A, option A, dP over dt equal to negative P over V. B, dP over dt equal to negative V. C, dP over dt equal to 0. D, dP over dt is equal to negative V dt. Option E, dP dt is equal to negative P over V times dV dt. And so take a moment and answer the question. Hopefully we took a break and observed that this problem belongs to the implicit differentiation. So that's what we're expecting to do. And this means that P and V are both functions of time, and K is constant. So I take the derivative of both sides with respect to time. And derivative of K is going to be 0 because it's a constant. This is a product rule, and what I get is basically dP dt times V is equal to P times dV dt. And then I solve, and in looking at what we see, we have to figure out how to match this one to one of the options. I see that options are solving for dp dt, so I solve for dp dt, and solving for dp dt gets me negative p over v dv dt, and that's option E. I click at question 5. If f is differentiable at x and its inverse function f inverse is differentiable at y, where y is equal to f of x, then which of the following is true? A, f inverse prime of y is equal to 1 over f prime of x by chain rule. B, f inverse prime of x is equal to 1 over f of x by chain rule. C, f inverse prime of y is equal to 1 over f prime of y. D, by chain rule, D, f inverse prime of x is equal to 1 over f prime of y by chain rule. E, none of the above. So if we write, how does f inverse work on f? It's f inverse of f of x equal to x, correct? And so basically, if I do a chain rule, what we get is f inverse prime at f of x times f prime of x is going to be equal to 1. Now, solve for f inverse prime of f of x, and you get this. This still doesn't look like any of those, except that I forgot to replace this with y. And now I have f inverse of y is equal to 1 over f prime of x. And so that would be option A by chain rule.